Welcome to section 6.4. We're now assessing normality. Basically, we can assume that certain things are normal: blood pressure, cholesterol levels, height, IQ scores. Sometimes we're told that data comes to us as normally distributed, but very often we have to assess whether that data is normal or not. So to do this, the first thing, if we can, is to figure out what the source of variation in the population is. And if there are a lot of different factors, some of which add and some of which subtract, then the distribution is probably normal. Now, if in your head you're imagining a Galton board and you're imagining balls falling and hitting pegs as likely to be adding, that is going to the right, as subtracting, that is going to the left, and there's lots of pegs and lots of balls, then you're thinking exactly what I'm thinking. That variation comes from many different factors, each adding and subtracting. Now, when we look at the histogram, it should be roughly bell-shaped. Now, there shouldn't be more than one outlier. So to find outliers, a nice way to do this, and this is what our calculator uses, it calculates the interquartile range, multiplies that by 150%, by 1.5, and if a value is outside that range of 150% of the interquartile range, then it is considered to be an outlier. There should be no more than one outlier. So you're allowed one, but no more. The normal probability plot is a sophisticated way of determining whether the data falls in a normal distribution. Our data will come to us as a random collection. That in itself makes it hard to determine whether it's normal. A normal probability plot is a very sophisticated analysis that our calculator can do. If the points in the normal probability plot lie close to a line, then the data is approximately normal. Let's take a look at our first example. For the Kiama blowhole, we're given the time in seconds between eruptions, and we're asked if this is normally distributed. If you go into our applications, in the Chapter 6 applications, you'll find a link to the data and the spreadsheet application in GeoGebra. So I'm going to copy that and I'm going to take it into GeoGebra. It looks like the 83 to 12 data is for the blowhole. So that looks like column B. There it is. So I've selected column B. I'm now going to perform one variable analysis on column B. And the first thing that it gives us is a box plot. We want a histogram. Now, the histogram doesn't look like it's very uniform. It very much looks like it's skewed to the right. So let's copy this as a picture. And let's paste this in. So we can resize it. And we can drag it in. So there's our histogram. And I think you'd have to conclude that it is skewed to the right. Let's go back now and make a box plot. And one of the things that we notice is that there are two outliers. I do encourage you to check that your box plot is showing outliers. This one clearly is. And there are two. Remember that we are allowed to have one, but in this case it looks like we have two. So let's resize that and put it in our box plot. So two outliers, so we can pretty much say that this is not normally distributed. That's one of our tests. But now let's look at the normal quantile plot. So when we select that, we can see that this data almost looks cubic. It's certainly not terribly close to the line. Let's copy this and let's paste it in, and we can convince ourselves that this did not give us a line. And so our conclusion, of course, is that we can be almost certain that the data for the Kiama blowhole is not normally distributed. Okay, now let's take a look at our next example. This is IQ scores. So we'll take this data. Remember, you can find it in the Chapter 6 application. So there it is, 78 and on. So I've copied and pasted it into the first column. So let's do one variable analysis for it. And let's get a histogram. And right away, this is looking very different. Let's export this as a picture and paste it in. It looks very symmetric, or at least reasonably symmetric, I'd say, certainly compared to the previous example. So our first comment is that the histogram looks symmetric. Now let's look at a box plot. Remember, it's always good to make sure that outliers are turned on. However, there aren't any, so that is another good sign. So let's plug that picture in for our box plot, and let's comment that there are no outliers. And then last, let's look at the normal quantile plot, and that data is clustered right around the line. So let's plug that in, and we can say that the data looks for all three tests as if it is normally distributed. So we're going to assume that this data is normally distributed.